I am Fraser Barker. I'm a fourth year computer games technology student, about to graduate. And yeah, today we're going to talk a little bit about my honours project. And with me
Cool.
here is Matt Bett.
Yep, I am Matt Bett. I'm a lecturer in computer games engineering at Abertay University, and I specialise in virtual reality and augmented reality research.
Cool. So a little about the project. Funnily enough, it started as an idea from my flatmate because it was like a few days before the proposal for the project. And he was like, "What if you do this?" And I was like, "That's cool." And at the time, I think I was trying to do VR and non-Euclidean stuff, which would have been really cool too, but it didn't really pan out. So I suggested it to my supervisor, Andre, and then yeah, he was like, "Well, if you can get the proposal in, we'll see if it can happen." So 4 days later, fired it in, and all the rest was history.
It's often the case with these things. Sometimes we have an interesting idea, and it
Oh
just
yeah,
happens and it works. So
yeah,
it's exciting to see what it is and how you manage to develop it and test it and ultimately see what we've got at the end.
yeah. I mean, the main motivation for the project really was that at the time I hadn't played an awful lot of VR games, but I'd watched a fair amount, and a lot of them seemed to be just floating hands or a floating head, which, it's fair enough. It cuts down on costs, and more often than not, it's a lot easier for the player to connect with it. There was a few titles, I think at the time, Boneworks had just come out, and that like solidified my thought process on that virtual bodies really helped the player connect with the game, feel more immersed.
Mm-hmm.
And that's why I set out to try and create one, really.
So that's where that was the inspiration and the motivation for it.
Mm-hmm. Yeah, just seeing if VR, like even with this lower end setup, sure, the mixed reality or Windows mixed reality headsets aren't top tier. They're a good entry headset,
Mm-hmm.
but it's good to see what sort of limits you can hit on lower end gear. See, okay, I've done this with the lower end stuff. What can I achieve with higher end units?
Mm-hmm. Yeah, exactly. These type of problems, if you solve them on sort of cheaper or less technologically advanced hardware, you're still solving the problems on the
Yeah,
expensive stuff the same. So it's good for that. So let's do you want to give a little demonstration of your project?
sure, we'll give it a go. See if it holds up and get prepared to stare at my torso for the rest of the call, so that'll be fun. Right, so hopefully if everything's going to plan, we see Unity. And if I go and step back, everything coming through okay?
Yeah, looks good.
Nice.
So
So a
just
little about
exploit
this
it.
scene. Yeah. So as most good sort of VR based games will allow the user to set their height, because in certain ones, no one's the same height really. And even when it comes to arm span and height, they can be two completely different measurements. So here I just try and get the user to measure their height by putting their arms out and pressing the grip buttons on the Windows Mixed Reality controllers. As you can see, that's calculated there. And the height is obviously from the top of the headset to the imagined floor, which is all set within Unity. And you can also toggle your desired height if you like. And then we just go into the next scene. And if all goes according to plan, there he is. So yeah, you can move the fingers in the general motion that usually applies to Windows Mixed Reality headsets. Fortunately, I didn't get the thumbs on the go, but it's added to the to-do pile, really. But if we see, yeah, the Kinect is working okay.
Ah, very good. Yeah. So it's more kind of you have more presence for your body's position and articulation than normal virtual reality.
Yeah. I believe if it works, here's my little bowling ball that I can grab. So these were some light additions, but just to sort of further the sort of goal of the project. So you can grab an object, you can holster it in this little holster on your arm. As you can see, it kind of sticks with you.
Mm-hmm.
And you can grab it off again if it doesn't want to roll away. No, it rolled away. And then, yeah, the tricky part, as with any VR things, is the motion. So I'm not too good at bowling. But, you know, with many iterations, I could probably get the whole flow. But yeah. Any questions on?
Oh, very good. So why do you think this type of virtual reality with the sort of extension of the body and whatnot will be important in the future and sort of going forward as VR technology gets better and better?
That is a good question. Well, as the first application that I'm interested in is games. So, you know, if you have a full body, you feel a bit more connected to the world. So, like, if you bump into a table, you can't just float through it. Certain games, like recent release Half-Life Alyx, it doesn't render the full body, but they do actually calculate, so you can't do unimaginary things. You can't just fly off into the distance.
Yeah.
But you know, there's other applications too. Like if you just wanted a face-to-face, like in these current times, you know, seeing the full body of your friend
Mm.
would be quite interesting. And I'm sure there's various other applications too. Like maybe if you wanted to delve into, I don't know, a VR movie and try and like record in engine or something, that'd be kind of cool.
Yeah, that'd be interesting. Um, do you think this is something that's going to manifest outside of games? Like obviously we've talked about communication. Any other applications outside of games you can think of? Or the real world?
Not at the moment. Those are the main ones, really. But you know, people are always applying VR to various different avenues. So I wouldn't be surprised if they end up applying it to wherever they like.
What about how this was created? Can you tell us about the hardware and software technology used to develop this?
Yeah, sure. So I used the Acer Windows Mixed Reality headset and a Kinect V2. So the Acer WMR headset controls your hands and the head, and the Kinect is used to control your legs. And the merging of the two, as you can see, gives you the whole body.
Very cool. What about software-wise? Is this developed in Unity?
Yeah, so it was within Unity for various reasons, mainly being that there was a lot of support and other people had delved in. Another option I could have taken was a DirectX framework, which featured the framework for Microsoft's mixed reality headsets, but that would have been a lot more involved. And there was no guarantee that the Kinect plugin would have worked there too.
Of course, yeah, because you would have to use plugins for the Kinect and obviously to get the headset working alongside it. I can imagine there was a couple of problems getting the Kinect to work. There usually is.
Oh yeah, the Kinect was a very fussy piece of technology.
Was it a Kinect 1 or a Kinect 2?
Kinect V2, so it was, you know, slightly higher res, but still, it was very picky about the sort of USB controller that it was using, which was fun, but that sorted itself out in the end.
Very good. What are your kind of next steps for the project? If you were going to develop it further, what would you do next?
So, I mean, current plans, as I think was pinned at the tail end of my dissertation, it would be quite nice to see if I could sort of roll it into a plugin for Unity. But obviously, as it currently stands, it only supports this headset, so I'd have to try and sort of unify it so that it works across, you know, first all the mixed reality headsets, and then, you know, you got the HTC Vive, you've got the Valve Index. There's just a plethora of other headsets out there to support. So that would be the main step. Alternative is I could sort of have it as a main feature in a game, but you know,
Yeah.
bit by bit.
It's quite interesting, even just hearing you speak and not looking at the video feed. You can actually see the virtual reality avatar emote and move and have body language quite naturally. So I can already see the sort of the appeal of having that
Nice.
for communication. It works quite well.
Nice. I mean, I can't speak for what the team's video feed looks like, but
It looks
it's
quite
mainly
good.
the project
Quite
we're
good.
interested in.
Yeah, that's good. I think that's very impressive, and it's a shame we won't get to see it and people won't get to play with it themselves. But I think it's a good
Yeah.
demonstration working with
Yeah, I
what
mean,
we
this is
have.
the next best thing,
Yeah, very good. Can
Cool.
you move around? I mean, very limited range.
Yes, so that was a funny thing. So when you focus on building inverse kinematic systems, you tend not to focus on if people can teleport around. So when I was doing user testing, as you do when you put on a headset, you play with all the buttons on the controllers. They ended up flying off and in weird rotations that it couldn't handle. So for the moment, you're stationary. But in earlier iterations, you could rotate and you could move a little bit. But merging the Kinect and the VR systems is a bit complex when you start doing that. Because, as you want to rotate, as is human nature, you turn your whole body. But that doesn't work because the Kinect likes a front facing user. Otherwise, its body detection sort of fumbles.
Yeah, exactly. Well, that looks good. That's an excellent,
Nice.
excellent demonstration. Thank you.
Thank
Thank you,
you.
Fraser.